An identity is an equation where all input values into our variable are true. Some examples of identities were given by trig identities. We had the reciprocal identities. Then we also had the even and odd identities. And the last set of trigonometric identities that we've seen before was the Pythagorean identities. Identities allow us to write expressions in different ways, oftentimes simpler ways. We'll use trig identities to simplify trigonometric expressions. Now let's go ahead and write tan theta cosecant theta in terms of sine and cosine, and then simplify the expression. Tan theta times cosecant theta can be rewritten as sine theta divided by cosine theta times 1 divided by cosine theta. Oops, that should actually be sine theta. The sine thetas cancel out and we're left with a 1 divided by cosine theta. So tan theta and cosecant theta written in terms of sine and cosine theta is 1 over cosine theta. To simplify 1 over cosine theta, we could just rewrite this as secant theta. Let's go ahead and look at another problem. We want to write cotan theta divided by cosecant theta minus sine theta in terms of sine and cosine, then simplify. First, we'll begin the problem by rewriting our expression. Here we have cotan theta divided by cosecant theta minus sine theta. Replacing cotan theta with cosine theta divided by sine theta, and replacing cosecant theta with 1 over sine theta gives us the following expression. Now we'd like to simplify the denominator, and to do that, let's multiply this sine theta by a sine theta divided by sine theta. We'll get that this is cosine theta divided by sine theta up top, and then on the bottom we get sine theta minus sine theta divided by sine theta. The upper sine theta is squared, and over here we still have root 1. And now we can combine the denominator into one term, which is going to give us the following. Again, the numerator hasn't changed, but the denominator becomes 1 minus sine squared theta divided by sine theta. Now the sine theta is going to cancel out, and we're left with this is going to be equal to a cosine theta divided by 1 minus sine squared theta. Now replace our 1 minus sine squared theta with cosine squared theta. This becomes cosine theta divided by cosine squared theta, which is equal to 1 divided by cosine theta. So this is our function rewritten in terms of sine and cosine, 1 divided by cosine theta. And if we wanted to simplify this, we could rewrite this as secant theta. And we're done. Let's look at another problem where we use trigonometric identities to simplify a trigonometric expression. So in part A, we want to simplify sine x plus tan x divided by tan x. This is equal to sine x divided by tan x plus tan x divided by tan x. The tan x's cancel out, and we're left with a sine x divided by sine x over cosine x plus 1. Our sine x's cancel each other out, and this simplifies to be cosine x plus 1. Now looking at part B, we want to simplify cosine x divided by secant x plus tan x. Again, we want to simplify the denominator, so let's rewrite secant x and tan x in terms of sine and cosine. This is going to then be equal to cosine x up top divided by 1 over sine x. Excuse me, this is a cosine x plus sine x divided by cosine x. Combining our fractions in the denominator, we get cosine x divided by sine x plus 1 divided by cosine x. This is equal to cosine squared x divided by sine x plus 1. Now we want to go ahead and replace cosine squared x with a 1 minus sine squared x. And 1 minus sine squared x factors out to be the following: a 1 plus sine x times a 1 minus sine x. All this is still divisible by sine x plus 1. Now the sine x plus 1s cancel out, so this term here and this term here, and we're just left with that this is equal to 1 minus sine x. And this is our solution. To end this section, we'll go ahead and review the last trigonometric identities that we've seen before, called the cofunction identities. The cofunction identities give us a relationship between sine and cosine, tan and cotan, and secant and cosecant.